Okay, we'll go ahead to start. So today is a Sunday. It's July 18th. We are very fortunate. We have a Dr. Ganesh Ramesh here today with us. And this is our Above and Beyond Leadership Association and Beyond Academy College Planning Services. So we put together these summer sessions. We invited a series of awesome professionals to share their careers with us. So today we are very honored and fortunate to invite Dr. Ganesh here. I'll just do a little bit of introduction of him. So he graduated from India Institute of Technology from with a master's degree in computer science, and then he went to the doctor of philosophy PhD degree in computer science at the University at Albany, and then he did a few years of a postdoc at the University of British Columbia, also in computer science. That's his educational background. For his work, he has worked for several different companies. And his recent work is in Apple. He's a data scientist at Apple. So today he has slides to share with us, and also he will give a chance to everyone to just have a conversation with him. You can ask any questions about the career, about his interest, about technologies. So with that said, I will give my floor to Dr. Ganesh. Please go ahead.
Thank you, Shelley. Thank you for the kind invitation and introduction. I hope all of you can hear me, right? You all can hear me. That's good.
Yes.
Okay. So today, let's talk about data science today. I just want to give you an idea of what data science is all about. And if you want to be a data scientist, what a typical day in the life of a data scientist looks like. Okay, just want to give you an idea of what we do and how life looks like in data science. Okay, again, in today's world, right, data scientist and being an engineer and a data scientist, the line is very blurry because you'll have to do multiple things, you'll have to have multiple hats. And engineer does the same thing, data scientist also sometimes does the same thing. So it kind of can be confusing as to what I'm talking about, whether I'm describing an engineer or whether I'm describing a data scientist. But that is deliberate, because the life itself is like that. It's defined like that. Okay. So let's talk about data science. Okay. So who am I? As Sherry mentioned, I've been a computer scientist all my life. I've been a serial data scientist. My research is mostly in data management and data mining. So post my education, I've been in the industry since 2005. I've been with Amazon, Microsoft, Yahoo, some of the big companies. I've also done my fair share of startups. I've spent a couple of years in a startup, and currently I'm at Apple. I'm in the field of artificial intelligence and machine learning. We build a lot of AI models day to day, right? So just a disclaimer, I'm not supposed to talk about what I do at Apple. So none of the work presented here has any connection with Apple. So I have to say this, and I cannot talk about anything that's coming up. Nor do I know, nor can I talk about it. So please don't ask me questions about what are the next things that Apple is going to come up with or things like that. Those things I cannot talk about. Okay, I'll talk about general data science today. Okay, and I just have to give the disclaimer. Okay, so how many of you recognize this screen? So you must recognize the screen, right? If you use Netflix, then you will see things like this on your main screen, right? It says continue watching. It says, and you have this list of crime movies, list of categories for you, e-station, TV shows, and stuff like that, right? You're very familiar with the screen. Okay, just hang on to this thought. I'll just show more screens and I'll ask you this question, right? So how many of you are familiar with this one, right? For example, this is a screenshot from Amazon. When you log into Amazon, you see recommended items similar to your past purchases. So what does Amazon do? It records, or it learns from whatever you buy in the past, And based on that, it shows items you're interested in, right? So things like recommended for you, recommended items, books you may like. Um, these are all things that Amazon does, right? Based on the information it collects from you and your browsing behavior and your buying patterns, right? And then again, more screenshots from Amazon. Because you shop for similar items, we are recommending these products to you, like the tripods on the top. Or based on the items you have viewed, it finds more items like the hard drives in the middle, or the USB-C port and the hard drives in the middle. So basically, and how about this from YouTube, right? When you log into YouTube, you see a bunch of videos that are out there, right? Now, these videos, they don't come up from nowhere, and they are not random, right? They have some semblance of what you are interested in or what you have viewed in the past, right? So if you have used any of these products, right? Amazon, Alexa, Amazon Prime, or Google, YouTube, Maps, Apple Music, movies, if you have used Instagram, Facebook, or even financial software like E-Trade or Ameritrade, or any travel products, like for example, if you use Expedia to book your ticket, Orbitz, if you have shopped at Safeway, if you have shopped at Costco, or you go to Starbucks, right? You have been touched by some form of data science, right? The products that any of these apps or companies use, or any of these physical stores use, right? They're all powered by some form of data science or AI, right? So what I'm trying to drive here is, no matter what you do in everyday life, right? You are touching data science some form or the other in a large way, unknown to you, right? You may be just browsing some stuff, but data science is touching you in some form or the other, right? So data science is powering, a whole lot of things, right? From serving up search recommendations all the way to kind of, recommending products that you buy, or even the ads that you see on any of the pages, or even when you use apps, you're touched by some form of data science or the other, right? So let's do a small story about data science, right? So back in time, right, before computers, right, you mean to say that there was no data science? Yes, there was data science. It was called just science, right? So people made observations about nature, they collected data, they observed behavioral patterns and made laws and generalized them into theories, right? They were also doing data science. In some sense, all the laws that you study in science, like physics, laws of motion, right? Laws of gravity, thermodynamics, no matter what thing you study in science, right? All those laws, they were all based off data from experiments, data from natural observations, right? Now, you didn't call it data science back then. It was just called science, right? So what is science? Science is the study of nature and its phenomena, right? You have physical phenomena, you have chemical reactions, you have biological phenomena, you have weather and forecasting, you have study of human behavior, So how do scientists go about doing their work? What they do is what we call the scientific method. What they do is they observe some phenomena and they make a hypothesis about it. Hypothesis means they say, oh, I see this pattern here. Let me just state it as a pattern. Let me say that, there is a pattern here, and I'll state that pattern, and that becomes a hypothesis. A hypothesis is something that you need to verify or prove, right? So what do? You set up an experiment, you measure something, and then you either verify the hypothesis or refute the hypothesis, right? So once you set up an experiment, you collect data, and these data, they are called observations, right? Once you have a bunch of observations, you use some kind of mathematical model or statistics in order to kind of infer a hypothesis, infer a theory that either proves your hypothesis or disproves your hypothesis, right? So this is the scientific method. So the scientific method is what led to, all these laws of motion, laws of gravity, all these laws that you read in physics or, chemistry or whatever, right? They come from this scientific method. So the tools used here are mathematics, statistics, And of course, when computers came into being, they started using computers because computers can help speed calculations a lot, right? Computers are extremely fast in computing things, right? Like in math. So they used all these tools later on to help with the scientific method, right? Fast forward to 1993, what happened? What happened? The internet happened, right? We started getting connected with, the world started getting connected a lot more. Technology advanced, and we could actually collect a lot more data. For example, in the 1960s or 1970s, you cannot imagine collecting 1 million records based on consumers' behavior every day, right? You have to like write it down in a ledger, and you cannot write 1 million entries in a ledger in a day, right? Today, whenever you visit Amazon, whenever you visit Apple, whenever you visit Google, for example, right? All these things are logged in the computer, right? So you get billions of transactions every day from Amazon, right? So e-commerce started to flourish, and because we get lots and lots of data and we store them in hard disks, we started mining that data. Mining means we started analyzing the data and finding patterns from it, right? So only by analyzing the data can we figure out that, let's say Sherry goes to Amazon and she likes like this $1,000 purse. So we can actually say Sherry loves purses, right? We can make generalizations like that. Or Sherry loves, let's say Coach handbags, right? For example, we can make an inference like that based on her behavior. I'm just using that as an example, Sherry. Okay. So what happens is, when we have all this data, then we can analyze the data and start creating patterns from it, right? Now, in the first decade of 2000s, what happened is the computers also started becoming really, really fast. So we had what are called GPUs. And because GPUs were developed, they made computation extremely fast. So you could really, really take all these AI algorithms and speed them up by a huge amount, right? So previously you could analyze, let's say, 1 million transactions. Now you could do 1 billion at the same time, right? Because of the computing power, you could do a lot more with what was being developed, right? And from 2010 to now, you just take data science and data engineering for granted, because previously in the early 2000s, only a few people were still doing a really good, sophisticated AI. But then now almost everybody does it, including all the startups. They actually, do all of this, because data is the new money, right? Because what differentiates people from other people is how much data they have and what kind of data they have, right? So the whole notion of data science was coined early in early 2010s. And, we had like these large scale data processing pipelines that could like, suck up all the data and spit out all these cool patterns based on which you could actually build products, right? So what's the difference between science and data science? Okay. The difference between science and data science is the word data, right? And that's a simple thing, because, in science, you have few observations, and you really, really hypothesize with very few observations, and you make a theory out of very few observations. Whereas in data science, what powers the science here is the presence of this large corpus of data. So that is the difference between data science. Data science means performing science over large means like really humongous volumes of data. I'm talking about billions of transactions in a day, or even tens of billions of transactions in a day, right? That is the scale at which I'm talking about. But because if you go and look at Facebook, for example, right, the amount of active users in Facebook every day it runs into the billions, and you get so many transactions every single day, right? So you're really talking about billion scale transactions. By the way, I just forgot to mention, feel free to ask me any question during the course of the talk. Sherry, if there are any questions in the chat, will you be able to interrupt me and read them?
Yes, I will. So for everyone, if you have any questions, you can either just start talking if you are a panelist, or you can just write your question in the chat box. We wanted it to be interactive. Okay, thank you. Just continue, Dr. Ganesh.
Okay, so basically, there is this huge, race for who has, the best algorithms, who has the best AI, who has the best machine learning algorithms today, right? And if you go and look at papers that are published, there are 1,000 papers uploaded every day on AI and ML. So if you want to really keep up with what's the state of the art, it's becoming really hard because there are lots and lots of people working on it. Okay. So what does it take for data science to happen? Okay, this is the steps involved in basically building a product out of data science, right? So what you do is you basically hypothesize about a product. And then based on the hypothesis, what you do is you collect data, you process and prepare this data. Then basically before you do any kind of modeling, you kind of figure out what's there in this data. So for that, you need what is called data analytics, data visualizations, and insights. So what you do is you just process this data and figure out, what's there in this data. Is the data really good? Is the real, or is there noise in the data? If it's crap, how can we remove the crap from the data, make clean data out of it, and then analyze the patterns in the data. Once you analyze the patterns in the data, then you start visualizing it and make hypotheses about this data. And then what you do is you model it using some mathematical model. You build mathematical models to verify these hypotheses. That's what is the experiment, right? The experiment will collect the data, build models, and verify your mathematical models. And then once these models are verified, then you can deploy these models into a product. And if the model is not so good, then you go and repeat this whole process, right? This whole process it revolves around data, how you collect the data, how you process the data, how you analyze the data, and what models you build out of this data, right? So I'm going to go into each of these steps in a little in the next few slides so that you get an idea of all the various steps and what. So by the way, one thing I have to tell you is data scientists do all of these, but there are dedicated jobs for each of these lines. For example, if you're just doing modeling and machine learning, then you're called a machine learning engineer, okay? If you're just doing analytics and processing and preparation, then you are called a data engineer, because today processing, preparation, and collection runs into petabytes and petabytes of data, right? So you need like large engineering platforms that actually collect, process, and prepare this data for you, right? So these roles are dedicated for what are called data engineers. And data engineers do a lot of infrastructure work. They build like systems that process data in scale, right? So depending on what kind of role you're looking for, each of these are combined into one role, or they are, individual roles in large companies, okay? So I can go into each of these based on what other clarifications you have, but let me just describe each of these in the next few slides, okay? So for data collection and processing and preparation, right? So we want to instrument the system to collect logs. For example, if you go and visit Amazon, so you have to log an event saying that, okay, Ganesh visited Amazon at some time on some date, right? And the processing pipeline will have to aggregate all these logs and clean them and store them into a structured data source, right? So this process is called the data preparation process, right? You collect the data, you process the data, and you prepare it, right? Now, typically these are called ETL processes. So what they do is they extract the data from the logs, they transform the data into some format, and they load them into some kind of a structured database or in a data, in a warehouse. It's typically a warehouse that stores all these logs, okay? By warehouse, it's not a physical warehouse, it's actually a data warehouse, okay? So that's what the ETL process is all about, okay? Once you have a warehouse, what you do is you run data analytics on top of it. So for example, it'll compute simple statistics on the data. For example, how many users are there? How many distinct users are there? How many of them are frequent users? How many of them are logging in for the first time, for example, right? How many videos were watched in the past hour, for example, or how many views did a video get, right? These are all things that you can compute using data analytics, right? And basically, the analytics that are interesting to monitor for a company are typically exposed in what are called dashboards, okay? Dashboards are something like these, for example, right? If you were so for example, consider a small business, right? So you may be interested in users by state. You may be interested in top sales category, for example. For example, a company like Macy's, right? Or a clothing store, they may want to know what are all the top sales by category, right? And for example, how many users were acquired over time, right? In 2016, how many users were there? In 2017, how many users were there? How do they vary over year to year? And what age groups were the users in, for example, right? These are some kind of tools that will or dashboards that will help you visualize how your company is doing, right? These are what are called dashboards, okay? And these dashboards actually expose metrics that are useful for a company, okay? And these dashboards, they also form into some kind of area called data visualization, okay? A data visualization is, if I give you a large table containing 1 million rows of data, it's going to be hard for you to kind of look into the rows and figure out what's happening, right? On the other hand, if I can present all the information in like easy to look at charts like these, then you can actually easily get an idea overall on what your data is all about, right? For example, these visualization tools present the data in a very, very concise manner to the end user, who's me, right? So data visualization is the process of designing all these pictorial descriptions of data, right? And the goal is to understand what is there in the data. And a picture is worth 1,000 words. So it can expose patterns and help gain deeper insights on what the data contains, right? By the way, data visualization is one of the tools that data scientists typically use, but it's a large field by itself, okay? If you think of each of these fields, there are people who do PhD in each of these fields, okay? That's how deep you can go into. It's a large field all by itself, okay? And think about it this way. Building some of these visualization tools itself is actually quite a challenge. And you can actually write dissertations, or you can do a PhD on coming up with these new tools for visualizing data, okay? So people have done a lot of work in just building these visual tools, okay? So for example, this one. So based on data that we have analyzed, right? If I give you a name like Alexis, right? Is Alexi a male name or a female name, right? So we have presented this data in a very visual manner. Like, for example, what it says is, if you're 0, which is if you're red, it means you're female. If you're blue, it means you're male, right? So what this says is, it depends on where you are from. So if you're in the US, it's red, which means most of the Alexis in US are actually female. Whereas we go to South America, and if you say Alexi, we are most likely a male. Because if you look at Europe, all of Europe, right? Alexei is a male name. Actually, if you look at a place like, Russia is absent here, but then if you go to France, or if you go to, Europe, most of the Alexis that you see are actually male names. Whereas if you go to United States or Australia, for example, they are typically female names. Purple means you're either female or male. You have equal representation of Alexi, who are male and female. Same here with Andrea. So if you look at Andrea, if you go to Italy, Andrea is a male, whereas everywhere else in the world, Andrea most likely is a female, right? So these are visual tools that help you analyze this data and kind of, these are insights that are very, very useful to you, right? If you're designing a product around it, then they are quite useful to you, right? So, okay, any questions so far, or you're good?
Let me ask you a question. So I used to learn a lot of statistics. At that time, we didn't call it a data science or data scientist. We just call it a statistician, statistics. Seems like a lot of things are similar, more like a data scientists use more computer tools to solve the statistics problems. Is that right?
So that's an excellent point, because many of the data scientists we hire are statisticians. They have a background in statistics. They have PhD in statistics. They have masters in statistics. They are the ones who actually get into data science. Okay. Now the the difference between a data scientist and a statistician is that data science, in addition to statistics, data science also need to know a little bit about how to scale those statistics, okay? Because statistics is just a mathematical field, right? Which talks about, populations and, laws about how you can analyze populations, how you can analyze data, right? These are, they're extremely important tools. However, how can you employ these tools for large populations or large data sets, right? That involves them to know a little bit of algorithms on how you can use these computing systems to scale these methods to large collections, right? So that is where the intersection with computer science comes in, because you need to know how to skillfully use computers to solve these large statistical problems, right? So you can say that it's an intersection, or it's a kind of a mix of both statistics as well as, raw computing, right?
Okay, so about the amount of data, so I was just trying to understand. So previously, as you said, we didn't have a computing tools. So when we were doing statistics, it's a smaller amount of data compared to what we are using today. Would you say it's 1,000 times more data or even more?
It's even more. Wow. If you look at early statisticians, right, they reasoned with population in terms of thousands. Yes. If you give them 1,000 data points, they'll be happy and they'll make statistical laws out of it, right? Whereas today, we are talking about billions of transactions in 1 second. Okay, so we are talking about hundreds of millions of transactions in a second, or billions and billions of transactions in a day.
Wow.
So think of it that way, right? So it's like 1,000,000 times more than the first few papers that were written in statistics, because they only talked about 1,000 observations or 2,000 observations, right? Today we have 2 billion observations in 1 day.
Wow. Okay. Now I know.
Yeah. So think of it this way: every single hour, Amazon gets, hundreds of millions of page views across the globe, right? Multiplied by like 24, you get like on the order of 3 billion transactions a day, right? And this is not just transactions, they store every single page view, right? So if you think in the order of page views, you get in the order of, trillions of page views in a month, right? So so that can be quite large, right? So you need to scale these statistical observations and methods to that number, right? So that is what makes it challenging for a data scientist.
Very cool. Okay, thank you.
Now you have these insights, and you have these analysis, and you have these observations. So then what? Then what you need to do is you need to take them and make them into theories, right? And that is what is machine learning. Machine learning essentially leads to systems that can be trained to automatically do stuff. Automatically do what stuff? Things like prediction, right? Can you forecast how many transactions you're going to have in the next hour? Can you forecast what somebody in your system is going to buy? For example, the next time Sherry comes in and visits Amazon, what should I show her that is going to make her buy a lot of stuff that she doesn't want? right? There's something called impulse buying, right? If I show you an attractive product, you'll buy it even though you don't need it, right? But it's going to make me money, so I'm going to like tempt you with things that you don't need, but you'll still buy, right? So and for things like YouTube, right? When you watch a video on my platform, I make money. So what are the most likely videos you're going to watch, right? So how can I predict that, right? How can I predict what the next video is going to be, right? So, and things become challenging here, because if you're a new user, I've never seen you before, right? How am I going to predict things for you, right? My system should be able to do that also, right? I should be able to predict what you're going to do too, right? And the system is not very dumb, right? Because based on what you click and what you engage with, I'm going to learn more things about you, right? For example, if you click on a James Bond movie, I know that you like spies and you like spy thrillers, right? I can probably show you more spy movies next time you come around, right? Or if you like Marvel, or if you like Avengers, I can probably show more Marvel movies to you. And I know that you're going to like superhero movies, and you're probably going to click on other movies that I'm going to recommend to you, right? So the system is not dumb. It's going to learn from everything you give us. Everything you give us is a signal, and we are going to learn from it. That's what the system is, right? And then it's going to use its AI in order to predict more stuff that you are going to like. And it's a vicious cycle. It's going to constantly keep learning, right? So that is what machine learning is all about. Machine learning, there are two types of machine learning. You are given examples and you build models to learn. For example, I give you a lot of images and I say, this is an image which is a cat, this is a dog, this is a cat, this is a tiger, this is a dog. Okay, now I have all these labeled images and I give you a new image. Can you kind of learn what the new image is all about, right? Human brain does it. So machine learning tries to kind of mimic the human brain in trying to learn from labeled examples. That is called supervised learning. For example, classifying fraud. You give bank transactions that are, either good transactions or bad transactions, and we tell you, learn from these transactions. And predict risk of default in mortgages, predict house prices for zip codes. All these are classic examples of supervised learning. On the other hand, there is something called unsupervised learning. Unsupervised means you're just given data, and you're just so if I just give you data and say, okay, go learn from this data, so you will not know what the labels are, what you're trying to learn. But what you will do is you'll look at the data and kind of organize it so that similar data is kind of grouped together, right? So typically this process is called clustering. And that is what one part of machine learning does. It does unsupervised learning, which means it clusters data into groups and says, okay, there is this large cluster which talks about animals. There is this large cluster of images that talk about landscapes and things like that, right? So that is unsupervised learning, okay? And there is a very new area called deep learning, okay? The deep learning is, this is a very hot area. It has been hot for about 10 years now or more. And this uses a technology called neural networks. And especially after computers became super fast because of GPUs, right? This deep learning really started taking off. And these are the ones that are really doing a lot of things that the human brain does, that we are good at, in visual object recognition, speech recognition, and things like that, right? So these are the ones that are really, really good. Okay. So deep learning is the currently new hot area that is very, very popular. Okay. So I've given you a description of various things. So what exactly does a data scientist do? So if you're doing business intelligence and reporting, then you're called a data analyst. Okay. If you're primarily doing tools and ETL, for example, extract, transform, load, you clean the data, you load it into a data warehouse and things like that, you are a data engineer, right? And if you're doing pattern mining, you're doing data analysis and insights, creating all those visualizations and stuff like that, you are actually a data scientist. And if you're mostly if you're doing machine learning to build products, you're either a product data scientist or you're a machine learning engineer, right? So what I'm trying to get at is the line between data science and machine learning engineer is very fuzzy, right? Sometimes they cross over in today's world. So if I may be called a data scientist, but I'm technically I'm an engineer, I'm a machine learning engineer. I may also be called a data scientist, but mostly in the field, data scientists stop with pattern analysis and insights. Okay, they don't go beyond that. Machine learning engineers are the ones who actually write machine learning code. They build models, they make it scale, and they actually deploy the models to production. I do all of it, right? So it depends on what you do, okay? But typically we do, on any given day, we do any or all of these, right? In a startup especially, you do almost all of it, right? There's no blur. Because you don't have anyone to wear one dedicated hat, you have to wear almost all these hats, right? So it depends on where you are and what you do. You may be doing one or more of any of these things I described to you. Okay. And I think that's pretty much what I have for you. I want it to be a little more interactive. So I'll open this floor for questions if you have any.
Hi, Ganesh.
Hi.
This is like one of the parents. My name is Ganesh. See, one of the questions normally comes in like, especially I'm also like from India, where I studied, and later I did study here in US too. But for like a first generation families,
Uh-huh.
say when you're approaching engineering mindset, going to engineering college or like taking computer science or some other subject, I feel like, of course, data science, it becomes part and parcel of any subject you take, because at the end of the day, you're analyzing data. It may not be even related to e-commerce. It could be a lot of other things too, right? Like environmental things, even the way we see, like the other day in our company, we are working on like wildfire analysis and other things. For me, like for youngsters, what do you think should be the right approach? Like when they try to observe data science in their mindset when they're going to college, do they like concentrate for dissertation or some other work? They should take live examples, or how they, what I want to say is how they can build interest around that subject, data
So
science
see, the
and data
point is
science.
like, okay,
Mm.
I'll give
Because
you
you have
one.
done I know you've done PhD too
No,
in
no, no. I'll give you one
environment.
example. Okay, this
Yes.
is a good question, but I'll give you the best possible answer I can tell you. So, see, it doesn't matter which field you go into.
True.
Okay, so you go into pure science, you will do data science. You go into engineering, you'll do data science. It doesn't matter which field you are in. You go into mechanical engineering, you'll do some data science. You do electrical engineering, you do data science. You do biology, you do data science. In fact, most of the data scientist positions that are open are in biological companies right now, basically because they do a lot of, biological experiments are, I mean, they're classic example of data science, basically because, biology is all about, it's an observational science. Biology is all about observations. Without observations, you can't make a hypothesis. Without a hypothesis, you can't prove anything. So all these sequencing, DNA analysis, DNA sequencing, genome sequencing, protein structure prediction, all of them involve data science. Okay, it doesn't matter. So again, my prep work is to stay curious. That's it. It doesn't matter which field you go into. You go into ocean engineering, you go into biomedical engineering, you go into any field, you have to have a solid grounding of statistics and mathematics. Because for any of these things to happen, you need to learn the basic language, which is mathematics, right? So I've seen a whole lot of people. So the thing I want to basically tell people when they want to choose a field is, choose a field that interests you. It doesn't matter whether it's psychology, neuroscience, chemical engineering, electrical engineering. It doesn't matter. Choose a field that interests you a lot. Okay, because ultimately, whatever techniques you learn to kind of get anything out of that field, you will learn. You will pick it up. So I've seen that happen, because biologists who come into data scientists are now machine learning engineers, because they pick up that skill in order to analyze that data, right? So you don't necessarily have to study a computer science background or a degree in order to kind of do data science, because you'll pick up those skills anywhere you want, because we are not in the late 90s anyway. We are now in the early 2020s, and most of these skills have enough material that democratizes the learning of that skill. So today, people choose a field because they like a field, okay? And they excel in it because they have enough tools available for them to excel in that field. So the only two things I would like to state here is the following. A degree in science or a degree in engineering, no matter which area of science you choose or which area of engineering you choose, right? They give you the basic building blocks of engineering. Okay. So what is the basic building block of engineering? Can anyone answer? I don't know. We have parents who are engineers too.
I don't think a lot of math, logic.
No, I'm not talking about subjects per se. So, it doesn't matter which field of engineering you do, right? You can do nuclear engineering, you can do biomedical engineering. It doesn't matter, right? At the end, if you have an engineering degree, people say, right, he thinks like an engineer, she thinks like an engineer, right? So that is a basic principle of engineering that a degree in engineering teaches you, right? That's why they say they think like engineers, right? So what it means is this: engineering teaches you how to decompose a large problem that is unsolved into small building blocks that are solvable, and they put together all these solutions to build a solution to a larger problem. Okay, it doesn't matter whether it's a mechanical engineering field or a civil engineering field or a chemical engineering field or a nuclear engineering field. It doesn't matter, right? You have a large problem, you decompose them into small solvable components, you compose all of them and make a solution for a larger problem. Think of it as a building block. I mean, you're a civil engineer, you're trying to build a large skyscraper, right? It boils down to how the foundation should be, right? And then what materials you're going to use. Once you decompose the problem into laying a foundation, okay, you work within the laying the foundation place, you solve that problem. Once the foundation laid, you start building one by one, one by one, one by one. You don't try to build the entire building in one go, right? You, of course, you pay attention to detail for all the components of that building. But then once it comes to a small solvable problem, you solve it. And then you compose all these solutions and make up the large solution. That is true with any engineering field. So when they say he thinks like an engineer or she thinks like an engineer, it means they know how to decompose a problem into small solvable components, solve them and compose them into a larger solution. That's it, right? Same with science. He is a scientist. What does it mean to be a scientist? A scientist is someone who can actually hypothesize, create an experiment, collect observations, use statistics to generalize or prove or refute that hypothesis, and then repeat this process in order to create scientific laws, right? That is true with no matter which field of science you choose, be it physics, chemistry, biology, it's the same. Atmospheric science, it's the same, right? Social science, still the same. Social science, we do it with human behavior, right? So no matter which field of science or which field of engineering you choose, they teach you some basic skills, which is how to be a scientist or how to be an engineer. It doesn't matter which field of engineering you go into, you will develop that skill no matter where. And then these skills, there are some generic concepts or generic skills that you learn, which are these tools like mathematics, statistics, calculus, all these basic mathematical fields, right? Because they are the language that these engineers and scientists speak. So if you're good at all of those, then you should have no problem going into a field, becoming a data scientist in any of these disciplines. I think it should be relatively straightforward. That is what I would advise. It doesn't matter whether you don't have to necessarily do computer scientist. These data science courses are basically generic courses that help you analyze different types of data. So you'll pick up some skills along the way. That's it. But many of these basic things, you already, any engineering or a science degree will lay these foundations to you, no matter what.
Yeah, I heard you and I agree with you. I actually have engineering degree. I just share it with them. I share these common sense too. So I learned like a building science. It's a mechanical engineering inside of the building for my bachelor degree and the master degree. And when I got on my PhD degree, I think I learned so much in mechanical already. So I was curious person, so I learned electrical engineering. Also electrical inside of the building. It's like not the electronics, more like the power. And then I am curious person, so I actually learned a lot of statistics. And for my startup work, I did machine learning, a little bit of machine learning, a little bit this kind of work. Of course, I learned data visualization, just being a curious person and want to understand those things. And of course, I also learned other things like finance, business, marketing, those kind of things. So that's just me. I'm a curious person. So I use the foundation Dr. Ganesh talk about. If you build very good foundation in math, in science, in how you think, and then you got a habit of working hard, right? And being curious person, trying to understand, trying to solve the problems. And then all the other things can come in later when you do the work. You can learn new things.
For example, to add to you, right? If you look at all the subjects in electrical engineering, for example, right? If you look at digital signal processing, digital image processing, they are all the ones using computer vision right now. They are all the ones that are using feature engineering and machine learning. So if you look at all these transforms, if you look at all the work done in Kelvin filters, for example, the Kelvin filters is basically an electrical engineering concept, right? A filter is nothing but, it filters certain types of signals and it allows certain signals to pass through, right? A filter is a generic concept, right? And these filters are actually used in our machine learning units right now, right? So there is a lot of inter-applicability for all the techniques you learn in one field that you can take and do it in other fields. For example, the process of control in mechanical engineering, right? The process of control is used so much in controlling models in our neural networks. So basically the underlying language is math, nothing but math, right? So if you understand that math and if you understand the language of calculus, you can do anything, right? In some sense. So
yeah. So with that said, there's one Yin Zhang asked a question about. She said, "Thanks for sharing your insights. What's a typical learning or career path for data scientist? Any resource for her to prepare for becoming a data scientist? What has a future focuses, like a future trend for data science? Because she's a student, she wanted to become a data scientist. So what would be the career path for her?"
Okay, it's a good question, but I'll answer your question in two parts, okay? If you want a specialized data science degree, you're going to be a data science generalist, which means that, you basically pair it up with computer science and data science, right? In some sense, because your specialization is now in, doing data science in a very scalable manner, right? But typically what happens is you combine data science with a domain. Okay, for example, you want to do biological data science, or you want to do like data science with respect to, like, let's say environmental science, or you want to do data science with respect to a certain field, right? Because typically what happens is if you're preparing for a data science generalist degree, then you need to know all the math that associates with that degree. For example, you have to be really strong in calc and statistics, probability, and reasoning, logic. You have to be very good in algorithms and data structures, because they are the ones that are going to help you speed up your data science algorithms, right? So if you're shooting for a general data science degree, then you better shoot it with some kind of foundations in math plus computer science plus data science. Okay, but if you are interested in doing data science in general should be coupled with some kind of domain. So that is going to give you the domain knowledge as well as the tools to kind of excel in that particular domain. So for example, if travel fascinates you, then do something with travel data plus data science, right? Or if you're interested in like the environment, then do environmental sciences and take data science as a minor, where you get all the tools to analyze environmental data. That way, you combine it with some kind of field where you're an expert in the field, but you're using all the techniques of data science to excel in that particular field. So there are two paths here, whichever way you choose, you get enough foundations in data science so that you can apply it to whichever field you want to work on. Does that answer your question? Or,
yeah, I think that's a very good answer. That's good. Let's go ahead to ask additional questions. So Hubert, you have a question to ask? Hubert.
Oh yeah, I have a question. So how do like data scientists make money?
How do data scientists make money?
Yeah.
They're extremely good in what they do.
Well, like, yeah, okay.
No, you got to see, the point is, it doesn't matter whether you're a data scientist or whether you are, a doctor, or whether you are you're a handyman or you're a carpenter. It doesn't matter. If you're really good, you'll make money. In fact, I can tell you, I mean, I'm not going to discourage you from not getting your degree, because you should all go to college, okay? But I'm telling you, nowadays a handyman makes a lot of money. A good handyman makes tons of money, okay? But for that, you got to be extremely good, okay? And becoming extremely good is really hard, no matter which field you pick, okay? I mean, believe me, I know a whole lot of high schoolers who are fascinated in becoming actors and musicians and, all that, painters and stuff like that. I'm not discouraging any of them. Okay, by all means, if that is what you like, go do it. But just like that, just like engineers don't have it very easy. Okay, you got to be extremely good in what you do. For that, you need to work really hard in honing that skill. Okay, so if you once you do that, then money is not an objective, it is a side effect. Okay, it's just a side effect. If you're good, money will come automatically. Okay, but you got to be extremely good. So you got to work on your skills. That's all I can say. Work on becoming really good in whatever you want to be good at. Okay, and once you're that, people will recognize you and they'll reward you for it, right? So if you want to be a very good data scientist, pick up all those skills and become really good at it, right? That's all I can say.
Yes, very good. So I still remember one thing my professor shared with me. I always remember that. So at that time, I was a student, right, in college, and he shared with us. He said, fill the knowledge into your head first, and then you will get the money filled in your pocket later. That's one thing I always remember. So that's the same thing that I just talked about. You just become really good at something, some field, working hard. And when you are polished in your field, you won't worry about money later. You are professional, you make a good income. You work for somebody or you can make a good products. I think that's the meaning. But some fields actually are easier. That's how I feel. Like some fields more, what to say, I don't mean it's easier. You still put a lot of hard work there. Like as we all know, like medical doctors, like computer scientists, those fields now have a greater needs than people who's doing music, like doing art. Music and art are good, but if you combine music and art with certain product designs, that will be more, have a more demand by companies, so company can pay your work. So that's my understanding. I just want to share with you. I know some students, they haven't thought that far yet, right? You just think of what I want to do in the future. I don't know yet. Just explore your interests. Very good question, Hilbert.
Again, you should also take it with a big pinch of salt, because we are all spoiled by being in the Bay Area. Because if you're anywhere outside of the Bay Area will feel like another world altogether, because the pace and the quality of life here is completely different from the pace and the quality of life elsewhere. Okay, so you should also keep that in mind, because if you want to live here and if you want to kind of have the Bay Area as your target, then you need to mentally prepare your mindset for certain things, right? Because I don't think you can, if you have an expensive lifestyle, you can be a teacher in the Bay Area, because it's going to be extremely hard. Whereas a teacher elsewhere may be okay, because the quality of life, and the quality and the cost of living and all that stuff, they may not be as bad elsewhere as it is here, right? So you have to kind of make up your mindset, okay, and then plan for it. That too.
Yeah, we bring a lot of reality to your life.
Yep.
I think finally it leads to passion and your interest, because once you start your passion, right, your teachers, your friends, everybody would help you in reaching your goal. Like assuming you take engineering or some other thing, even literature also is good scope, has a lot of scope actually. So I think it finally lies on the interest of the student.
Oh yes, that is definitely true. I mean,
Right.
first of all, the student has to be interested in the field, right? I mean, that is a very big challenge too, because I don't know what kids are interested in nowadays, and they also, I mean, it also changes, right? Because initially they'll go into a field, they'll think something it is, the expectations will be something else, and they'll change. It'll take some time for them to arrive at a fixed point, but once they arrive at a fixed point and they know that this is what I want to do, then things will start moving along.
Yeah, that's good. And I know Dr. Ganesh has to leave for another commitment.
Yep.
And so we'll cut a few minutes short for today's webinar. So we'll say thank you, Dr. Ganesh. And can everybody say thank you? Just say thank you.
Thank
And
you,
we
Dr.
really
Phil, for having me here.
enjoy your talk. Yeah, thank you
Thank
so
you.
much. Yeah.
Thanks,
So
Ganesh. Thanks.
for the rest of you, we want to tell you next week, Sunday, 4 p.m., we will have another program manager from Google, and it's a very successful professional, and she will share with us the program management, and she has a Google also that's the company's experience, and we welcome everybody to come back. Okay, we'll have an interesting talk the next week. I will say bye-bye to everyone. Enjoy.